Welcome to this explainer. You know, when we talk about the hunt for extraterrestrial life, most of us immediately picture massive telescopes pointing up at distant, swirling galaxies, right? But what if I told you that our gaze into the cosmos is actually starting a whole lot closer to home? In fact, it's starting at the very bottom of the ocean. NASA, yes, our space agency, is currently hunting for secrets buried 10 kilometers underwater. Okay, let's dive into this because it feels like a total paradox, doesn't it? The United States already has a massive, dedicated organization for ocean research called NOAA. So why on earth is NASA sending an autonomous underwater vehicle named Orpheus 10 kilometers down into the deep sea? Have they found alien life down there? Well, to understand their ultimate goal out in the stars, we first have to understand exactly what they are doing underwater. Just off the coast of Florida, sitting at a depth of 20 meters, is the world's only underwater laboratory. It's called the Aquarius Reef Base. And get this, every single year, NASA sends a team of researchers and astronauts down to the space to live for weeks at a time. They run a very specific program called Project Nemo. These scientists are quite literally referred to as aquanauts. But why the ocean? Well, the famous geophysicist Edward Bullard actually made a brilliant point about this. He noted that even though 2/3 of our planet is covered by oceans, today we actually know more about the detailed maps of the Moon and Mars than we do about our own ocean floors. Reaching the bottom of the sea and doing actual research down there is vastly more difficult than mapping a neighboring planet. To truly grasp that level of difficulty, you just have to look at the pressure. For every 10 meters you go down, the water pressure increases by 1 atmosphere. You probably remember the tragic incident with the Titan submersible. That sub was roughly 3.5 kilometers below sea level when it imploded from the extreme pressure. We're talking about an event so instantaneous, happening in less than a single millisecond, that the human brain wouldn't even have the 25 milliseconds required to register pain. It is an incredibly hostile environment. And yet, remarkably, NASA is planning to send technology 3 times deeper than that. They're doing this because the extreme deep sea holds the ultimate proof of concept for an upcoming alien exploration mission. NASA knows that life on Earth started in the deep ocean, so they are hunting for those exact same conditions elsewhere. According to their scientists, there are 3 absolute basic criteria required to birth life in any environment. Number 1, water. Number 2, energy. And number 3, chemistry, specifically fundamental elements like carbon, hydrogen, oxygen, and sulfur.
Now, what's really interesting about this slide is that even if you have all the right elements just sitting there together, life isn't going to spontaneously spark. You need a catalyst. Think of it like making a cup of tea. You can have the tea leaves, but without a medium, water, and a powerful energy source, heat, you're not getting tea. In the exact same way, those raw chemical building blocks require water and a massive energy source to interact and actually spark biology.
A lot of people naturally assume that this energy must come from the sun, but that's a huge misconception. Life doesn't strictly need sunlight, it just needs energy. And this brings us to the Hadal Zone. This is the absolute deepest part of our ocean trenches, reaching up to 11 kilometers deep. Down in this pitch-black, incredibly dangerous terrain, we find hydrothermal vents. Basically, these are underwater volcanoes, constantly erupting with boiling water, steam, and minerals.
The water blasting out of these vents hits extreme temperatures. We're talking roughly 400 degrees Celsius. That is literally hot enough to melt solid metal. And this heat doesn't come from the sun at all. It comes directly from the Earth's extremely hot molten core. It was this exact geothermal energy that allowed the first complex biomolecules, like proteins and RNA, to form. That crazy chemistry birthed the very first unicellular bacteria, completely independent of sunlight. This is exactly how life began on Earth, and it's the exact model NASA is using right now to hunt for life on other worlds.
So acting as cosmic detectives, we have to ask ourselves, where else in our solar system can we find these highly specific conditions? Let's look at the suspects. Mercury, way too close to the sun. Venus, far too acidic. Mars, we're actively studying it, but so far, no flowing liquid water. What about the planets past Mars? Well, Jupiter and Saturn are gas giants. They don't even have a solid surface, let alone oceans.
Section 1. The prime suspect. Jupiter's icy moon, Europa.
Thanks to data from the past Voyager and Galileo missions, we know for a fact that Europa is hiding a massive saltwater ocean right beneath its solid ice shell. So, the crucial point is, how does that water stay liquid when it's so incredibly far from the sun? The answer is a phenomenon called tidal flexing. Because Jupiter is so incredibly massive, Its intense gravity constantly stretches and squeezes Europa as it orbits. This generates internal geothermal energy, acting exactly like those hydrothermal vents down in Earth's deep oceans. When we look at the actual numbers, the scale is just mind-blowing. It's estimated that Europa's hidden ocean contains roughly twice the amount of liquid water as all of Earth's oceans combined. Think about that. With a geothermally active core, a massive saltwater medium, and the known presence of fundamental elements like carbon, oxygen, and sulfur, the chances of finding hydrothermal vents, and thereby the identical fundamental biochemistry for life, are incredibly high.
Section 2. The Grand Space Pinball.
To actually go all the way out there and find proof of life requires an awe-inspiring logistical feat. To give you a real sense of scale, let's compare it to the highly celebrated Chandrayaan-3 mission to our moon. To get there, that rocket orbited Earth 5 times just to build enough momentum. But Europa is almost 1,600 times further away. If flying to our moon is like walking to the building right next door, flying to Europa is like traveling from Mumbai all the way to Delhi. The distances are just staggering.
To cross that vast, empty distance, the Europa Clipper spacecraft, which launches in October 2024, will take a highly calculated 7-year journey. It's going to launch, fly all the way to Mars to use the planet's gravity for a slingshot effect, boomerang all the way back to Earth for another massive gravity assist to build up maximum speed, and then finally shoot out toward Jupiter, arriving in 2031. It's literally playing pinball with planets.
Over those 7 years, scientists have to perfectly calculate the exact future positions of all these planetary bodies. The spacecraft has to expertly dodge harsh solar winds, navigate straight through an asteroid belt containing millions of space objects, and avoid the gravitational pull of hundreds of other moons. It is an absolute masterpiece of orbital programming.
Now, let's look at the arrival protocol for when the Clipper finally reaches Jupiter in 2031. It can't just hit the brakes instantly. It has to perform multiple flybys of Jupiter's other massive Galilean moons just to slow down enough to carefully insert itself into Europa's orbit. Once it's there, the primary mission begins, scanning the environment, the gravity, and the temperature, and beaming that precious data back to Earth. But really, that's just phase 1.
Because to actually find life, we have to get past a giant physical barrier. Data estimates suggest that Europa's outer ice shell is anywhere from 2 to 20 kilometers thick. That is a massive, impossibly dense, frozen shield protecting the ocean down below. So, how do we actually get through it?
And this brilliantly illustrates the sci-fi extraction phase that NASA is dreaming up right now. Following those initial orbital scans, future missions aim to actually land specialized rovers right on the surface. The plan is to deploy nuclear-powered cryobots that will literally melt their way through miles of solid ice. Once they finally breach the ocean, they'll release an array of 48 swimming micro-robots that will fan out through the alien waters, independently hunting for biological signatures. I mean, it sounds straight out of a movie, but this is real science.
Section 3. The Ultimate Human Pursuit.
As we prepare for this monumental leap in exploration, we really have to pause and think about the philosophy of what we're doing here. Because there is a massive catch we have to acknowledge. We are searching for life using the exact model of how life evolved on Earth. But who's to say an alien life form even has to be water-based? What if they don't use DNA at all? Our Earth-centric model might actually be extremely rare, and we might just be barking up the wrong tree entirely.
Yet, even knowing the odds of finding life might be as low as 1%, the global scientific community is pushing forward anyway. This mission unites the absolute best minds on our entire planet. We're talking about people looking past borders, past nationalities, and past self-doubts to work shoulder to shoulder. This is humanity at its absolute best. Even if we completely fail to find life, the revolutionary technology we create and the pure drive to push our boundaries empowers literally every domain of human civilization.
It reminds us of a fundamental truth about why we do this in the first place. Let curiosity be the ultimate driver of your life, because there is always so much to learn, so much to explore, and so much to grow. This mission is the very embodiment of that curiosity. So, I want to leave you with this to ponder as we look toward Europa and our own deep oceans alike. Are we truly alone in the universe, or are we simply searching in the wrong way? Thank you for exploring this fascinating topic with me today in this explainer. Keep your curiosity alive and keep learning.